Hello there, Marcelo here, and today we're going to be talking about the command pattern. As always, if you like, let me know. If you have any comments, go to the comment section, and for further information, you can get the description of this video. Okay, so let's go to the line that defines what the command pattern is. So the command pattern is useful in situations where you want to decouple the requester of an action from the object that performs an action, need to support undo redo functionality, require flexibility to dynamically change or extend commands, or aim to encapsulate requests as objects for easier management and organization in a software system. Okay, we're gonna go through our example here, and then we can come back to this definition and perhaps you're gonna understand this better. Okay, this pattern can be split into three main components: the receiver, the invoker, and the command. So let's talk about the receiver first. So the receiver here, in our case, in our example, is going to be the television, where we do have two things that you can do with this television: turn on and change channel. Of course, we could have as many as we wanted here, but this is just for the sake of the example. Okay, so this is going to be the receiver of the command in our case. So we need to understand what the command is. So let's go to the command. This is going to be just an interface where we do have all of the commands inheriting from it. And the basics of a command is that it has a receiver, so the ones that will really take the action, and the execute method, which in this case is not implemented, and that's why it's raising a not implemented error, because we are using this as an interface. So because we do have two methods in our television here, we're going to use two different commands for each of them. So the first command here that's going to be used to turn on the television will only pass by the command directly to the television. So in the end, in this case here, in the turn on command, what we just need to do is to pass on to the television. If the television is already on, it's okay. If it's not on, then we're going to get it is on. Okay. The second one, the change channel command, is also just passing by the action to the receiver. But the idea here is that because we have the command and we have the receiver, we could have done lots of validations first. For example, change channel. I can only change channel if the television is turned on. Otherwise, I cannot really change the channel because I have no channel selected on a turned off television. But we could have also, do we have electricity here? Is the television on then? So we could have lots of things that we do before. So the idea of the command is to encapsulate everything about getting that action done. So we do have an action. We do have someone that does want to do this action. It will call the command. The command will do whatever it takes to pass by the information to the receiver. So in the end, the receiver is doing the action, but we could have other things done inside of the command. So that's the part of the command. Okay, and that last part, the invoker, is the one that really needs that action to be done. In our case here, we're gonna say that the invoker is the remote control, but we could have even the person that's sitting in the sofa doing being the invoker of the action. So how is the invoker in this case being done? We do have a commands list in here inside of the remote control, and then we can add new commands to the remote control, of course. Where we do have the command key and the command. So this is gonna be more or less the button. So the key here that is the name in the button for that sake. And then we have the press button action or method here that is more or less as execute command. So the idea is to get that command and then we can execute it. So if it's present, of course. And if it's not present, we just say, yeah, I don't know what you're trying to do here. You press the button that does nothing. Okay, so as usual, we can test it out in our terminal here. So let's do it. Where's the terminal? Yeah, IRB. Okay, so we do have the three of them, the invoker, the receiver, and the command. So let's instantiate them. So we're gonna have the television, the turn on command, and the change channel command. Okay, now that we have the three of them, we can build our remote control where we do have the turn on command and the change channel command. Okay, now if we do press the button, which is same as execute command here for turn on, television turned on. And if I do that for change channel, television changed channel. So as you can see, what we have done here is that we decoupled the requester, in this case the invoker of an action, from the object that performs the action, which is basically the receiver. And of course we could have done some intermediate steps here inside of each of the commands so that we could call the receiver with the correct params. Okay, this is more or less the idea of the command pattern. Let's get one more complex, and then I will add up some of the things that I like to do when I do have the command pattern myself done. Okay, so here's another example where we do have a chef being the receiver, and the chef can make meals for you. So that's the idea of having many meals, many commands for that sake, and then people asking to get those meals done so that they can eat. Okay, what changes here? In here, my command interface now do not have only the execution of it of our method, but also it handle errors. This is the way I like to do this command pattern. So this is a little bit of Marcelo commands pattern here, but yeah, still more or less the same idea. Why? Because if I do have any errors, I would like to have them either fixed or passed by upon the chain so that we could fix it at some point, or even to just show the user that there was an error. So if any errors, then we have errors, and then we can get the errors as part of it, as part of the output here. Okay, and the input, I am put in an open struct here so that we can do input dot and then the names of the inputs. So our receiver here, the chef, if the order is fish, we are running out of fishes, so this is one error that we're gonna mimic here. And here's your order. Whatever other orders that are there, the chef knows how to do so, and then the chef will do it for you. So the cook fish command here will also get the receiver as in the previous example, and then we're gonna pass by this order passing fish. Why? Because we do have the input now. So we're gonna put the order as part of the input, so I can get input.order directly here. Okay, so when I do execute this, I do get the output, and if there are any errors, well, I just get those errors and I save inside of the errors, which is part of our command interface. Okay, cook meat is gonna do more or less the same, but because I do not expect to get errors here, I'm not taking care of errors right now. We could have, yes, but we are not. So imagine that we had different things in here, get ingredients or whatever, we could encapsulate inside of the command, and then the command would pass by the details of an order, for example, for the receiver, right? Okay. Now we have the invoker, which is the waiter. So the waiter is the one that's gonna take the order and pass by to the chef. So this is basically the idea that we have here as a command pattern. So a waiter takes orders are done by the chef. So this is one of the best examples you can come up with when you're thinking about the command pattern. So the waiter can take the orders, and then it will deal with errors. So if I can execute the order, passing by to the chef the order, then it's okay, I just get the command output here. But if I cannot, so if I get any errors, then I will just say, sorry sir, but, and then I can show the error to the one that was ordering it in the first place. As you can see, there is a difference here where I do have the chef as part of the invoker, so that we do have just one chef passing by. So this is one of the changes that I do also myself. And of course, here are the commands, or the menu that we have. So the waiter also holds the menu. It knows what is in the menu, even if something is missing. It's in the menu, but it's missing. The waiter is the one that will tell you that something is missing because of any reasons. Okay, so let's try it out again. Oh, I need that because it's an open struct. So let's clean that up and then we can just go for it. Okay, so let's get the waiter created. Oh, damn, I did not call the waiter created. And waiter, take order, meat. Here's your meat. Good, so it works. Now, if we do have an error, which is the case of fish, because we know that the fish, we are running out of fishes, what happens then? Sorry, sir, but we are running out of fishes. So in this way that I like to do, you can encapsulate errors and then you can take care of them in the right places. In general, when I am using the command pattern, I do even get rid of the invokers. Not true like that I get rid, is that I do have way too many invokers, so that I have the command as something to encapsulate logics and steps to be followed to get something done. So if we go back here to our definition, the last part, which is aim to encapsulate requests as objects for easier management and organization in software system, is the most common usage I do have when I'm using command pattern. I like to have them as telling my story or show you how to do an action inside of my system, so that it can be reused everywhere and people know that the results are going to be either successful or an error that I can take care of. I hope you have liked this video as well. If you do, please like it, comments in the comments section, and check out the description for details. See ya!